Welcome to section 9.3, hyperbolas. This is the third conic out of the four. Just to kind of jump right in, a hyperbola is a set of all points in a plane where the difference of whose distance from two distinct points, called the foci, is constant. If you remember with an ellipse, it was the sum of that distance of the fixed points that was constant. This one is the difference of the fixed, whose distance of the two fixed points is constant. So look at the difference between a horizontal and a vertical hyperbola. First off, identify those things that we talked about the other day with an ellipse. The distance from the center to the vertex, you can see right here, the distance from the center to the vertex is still A. So that hasn't changed. It's not called the major vertex, but it's called, it's the main vertex. It's the one vertex we have on the hyperbola. So that stays the same. We also have the distance from the center. Now, once again, we don't have a minor vertice, but there's this distance, there's this box that we have going around that I'll kind of explain a little bit later, but there's that distance that's going to help us create that box. So we're kind of pretending there's a something there, but it's not a point, it's just what's going to help us create that. So that will be B, similar to an ellipse. And then you also have the distance from the center to the foci on each of these. And that distance, once again, is C. And you can see that on an ellipse, the foci was inside the ellipse, and since the hyperbola is going to be going kind of opening outwards, the foci is now on the inside of the hyperbola, but since it opens out, it's farther out from the center. So some things just to kind of talk about and recognize. We have these lines right here. These are asymptotes. The graph will approach those lines but will not touch them, and so we're going to draw those in to help us get a better picture of what the hyperbola is going to look like. And you have the vertical, same thing, center to vertex is the A value, center to the other side of the box is B, and then center to the focus is C again. Look at your two equations, very similar. The difference between an ellipse and a hyperbola, if you look in between, there's a minus sign. So that's how you're going to tell the difference between an ellipse and a hyperbola, is that you're going to be subtracting the square terms instead of adding them, which is what happens on a circle and an ellipse. The other thing you want to pay attention to is look what happens to your terms here. You have your x squared term first on a horizontal, so think x-axis. Once again, the positive squared term determines the orientation. So that would be a horizontal parabola. This one, the y squared term, is first. It's your positive term. And it's, once again, think y-axis, and it's a vertical hyperbola. So everything's the same except the x and the y. Whichever one is positive is the one that determines the orientation of how the hyperbola is going to open, left, right, or up and down. On the next slide here, I just kind of go through some of the information. Just like we did the ellipse, we got something called a transverse axis. This is the length of 2A. This is what we call the major axis on the ellipse. It contains your foci and your vertices. Once again, we don't have major vertices, we just have the vertices. The conjugate axis is perpendicular to the transverse axis. This is similar to the minor axis of an ellipse, and it's the length of 2B. And then we have these asymptotes. The asymptotes are the lines that I was telling you about in the graph that they pass through the center and the corners of this rectangular box. The rectangular box is the A and the B values. So the A and the B values create that rectangular box. And really all that does is help us graph those asymptotes pretty quickly. We know the center is HK, so now we've done center of a circle, center of an ellipse, and center of a hyperbola, and they've all been HK. The distance for the foci is still C. That hasn't changed. The distance from A is the distance to the vertice, or the what we called the major vertice before. Once again, that hasn't changed. And the B is the distance from the center to that outside of box. That was the minor vertice for an ellipse. For this one, it's not a point on the graph. It's just going to help us create that box. And then what we have here is 2B is the length of the conjugate axis, and 2A is the length of the transverse axis. Once again, when we work backwards and I give you that information, that's what it's going to be talking about. What are the equations of the asymptotes? Well, if you're looking at a horizontal asymptote with a transverse axis, your equation is going to be y equals k plus or minus b over a times the quantity x minus h. And you might be looking at that and being like, you know, what is going on here? What is happening here? This actually is the equation. It's not in slope-intercept form. It's actually in point-slope form. So if you remember point-slope form, it was y minus y sub 1 is equal to m times x minus x sub 1. This is just rewritten, so it's y equals that y sub 1 value, which will end up being your k value of your point, which is the center, and then plus or minus the slope, that's the b over the a or the a over the b, and then in this case it's x minus h, because that's the point that we're using. The point that we're talking about is going to be the center, hk. So that's why the h and k is in there, because we're talking about the point through the center, or the line through the center, and the slope will be the b over the a and the a over the b. And I'll probably go over that a little bit more in detail in class to kind of make sure that you understand where those values are coming from. And then the last thing is the relationship between a, b, and c. With an ellipse, it was a squared minus b squared, because a squared was the largest value. But in this case, which value is going to be the largest? Which one's farthest away from the center? And that's the c value. So on this one, your c value is going to be the largest one. So it's a squared plus b squared is equal to c squared. So there's all the information. We're going to do the same three things that we've done on all the conics. We're going to graph it, we're going to write the equation, and then we're going to work backwards. So in the first one here, we have an equation written for us. Let's just kind of go through all the different things that we need to know. First thing, is it horizontal or vertical? Well, the positive term determines the orientation. So since the y squared is positive, think y-axis, okay? And then the y-axis is vertical, so therefore we know this is going to be a vertical hyperbola. The a squared is not the largest. With an ellipse it's the largest, but with a hyperbola, if you go back and look, the hyperbola, the a squared, is always the one with the positive square term. So it's not always the largest. In this case, it's not the largest. It's 9. B squared is 16. And then c squared is the foci. Those are the farthest points on the outside. So you add those and you get 25. Now on this one we get some pretty nice values, no square roots here. The center is hk. Now be careful, because h is always with the x value. Because our y squared is positive, it goes first. So our h value is -2 and our k value is 3. So you just got to be aware when you're looking at this that you're paying attention to where that squared term is, and don't just read it in order. So the center of this one is -2, 3. Vertices, those have to do with your a value. Foci have to do with the c value. So if this is vertical, so once again kind of visualizing vertical, we're moving up and down, that's changing the y value. So the y value is at 3. We're going to take -2, that will be this, that'll stay, and then we'll do 3 minus the a value, which is 3. So that would be at -2, 0. And then you would do -2, let me rewrite that, -2, and then we'll do 3 plus 3. And that will be at the point -2, 6. Now once again, we could just count, because we could put the center on here at -2, 3, and then we could count 3 units down. That would be at -2, 0. I have that one. And if we count 3 units up, that's going to be at -2, 6. So we can always just count, but remember, all we're doing is adding and subtracting to the y value. The next thing is the foci, which is your c. So we're going to count c units. Now that's 5 units. So we can go over here and count 5 units up. That's your foci. Count 5 units down. And that's your other focus. And that's changing once again by changing your y value by 5. So on the foci, it'll be -2, 3 minus 5 would be -2. And if you do -2, it'll be 3 plus 5 is 8, and you can double check those points, and that's where their location is. Now I'll get to the asymptotes in just a second, but let's go ahead and finish the graph. The b value is 4. Now when we go and count 4 over, we're going to count perpendicular to that. Now this is not a point over here, this is what's going to help create that box. So what I'm going to do is create, see if I can get everything kind of set up here. Alright, I think that's good. And so I'm going to create the box around the A and the B value. Alright, so it's going to create a rectangle. Doesn't matter if it's horizontal, vertical, whatever. That's not what we're looking at. This is a vertical hyperbola, so it should be opening up and down. Alright, the lines that we have here, I'm going to make it dotted because it is an asymptote, are going to intersect the corners of the box here. Let's see if I can extend that out. There we go. And so those are your asymptotes. Now I haven't really wrote the equation of those, but that's where they're located. So where is the hyperbola? Well, the hyperbola has to cross. Let me just change color so you can see this, so it's not all the same. The hyperbola will get close to the asymptote. It'll touch the vertex, and then get close to the asymptote on the other side. And remember, this is vertical. It should be opening up and down. So it's going to cross through the vertex, and then once again get close to the asymptote on the other side. The focus or the foci should be inside, or if you want to say outside the hyperbola, they're farther away from the center. And so graphing wise, we're done. Now it's just a matter of, okay, what are the equations of those asymptotes? And if you look at them, they don't really cross the y-axis nicely. So it's not that you're going to be able to write them in slope-intercept form very easily. And so this is where we go back to writing the equation, you know, given this point, which is hk, or in this case it's the center, -2, 3, and then the slope. Well, what's the slope? Well, I just look at the equation. The slope is going to be rise over run. So you're rising 3 units and you're running 4 units. So your slope is 3/4. And so we know the slope is 3/4. Yes, that is A over B, but I don't really look at it as that. I just look at the picture and as to what that represents. So the equation will be y equals that k value, which is 3. Normally we do, you know, y minus k, but since we added it to the other side, so it's y equals 3 plus or minus. The plus or minus is because you can go 3 units up, 4 units to the right, or 3 units up, -4 units to the right. So it's plus or minus 3/4, and then x minus the x value of the center, which is x minus -2, and that's plus 2. So there are 2 asymptotes here. It has the 3 plus or minus the 3/4. And so that's what you have for your asymptotes. Alright, so that's how you graph a hyperbola. Let's go ahead and move on to the equation. So I'm going to give you an equation just like we did on the other ones. We're going to write this in the correct form. This is just like an ellipse. There's, you know, a couple of things that I'll talk about as we move through this one as to where some of the hang-ups are, and why we have some of the mistakes that we do on this. So let's just go ahead and get it in the correct form. Y squared minus 2y plus blank. I didn't have to factor anything out on that one, but on the next one I do. I have a -4x squared, so you have to factor out a -4. That will leave you with x squared. Now remember, this was a -16x, but you factored out a -4, so -16 divided by -4 is a positive 4x. So you are going to see that sign change, and just kind of real quick to show you what just happened, if I distribute this back in, this would be -4x squared minus 16x. So that's why it works out there. And now that is equal to, I'm going to subtract the 1 to the other side. And then now we're going to complete the square just like we did before. So let's see what happens here. Take half your middle term and square it. So -1 squared is 1. So if you add 1 to this side, you have to add 1 to this side. And then on this one you have half of 4 squared. So if you add 4 to this side, you should be adding 4 to this side. Except wait, we didn't just add 4. This is 4, -4 times x squared, -4 times 4x, and -4 times 4. So we actually added a negative 16 on this one. So now let's go and factor this. This would be y minus 1 squared minus 4 times x plus 2 squared, just factoring those trinomials, is equal to, looks like negative 16. And so just like an ellipse, you want it to equal 1, so we're going to take everything and divide it by negative 16. And that's going to give us negative. And usually when you see an equation of a hyperbola, it's written where the positive term is first. So that's actually what I'm going to do here. My positive term actually got switched because negative 4 divided by negative 16 is we're going to reduce to positive 1/4. So I'm actually going to write that one first. We're going to write the positive term first. So x plus 2 squared over 4. And then this one is 1 divided by negative 16. So that's minus y minus 1 squared over 16. So that negative stays with the y squared. And it's equal to positive 1. So that's the equation of the hyperbola. And then we can talk about all the other things that happen, horizontal, vertical, and everything else. But once again, working on graphing, working on writing the equation, and then the last thing is we'll work on working backwards here. So we'll take a look at some more of these in class, but there's an example of writing the equation. And then the last example we're going to do is we're going to work backwards. Once again, I might just stop the video at this point and see what you can do in terms of working backwards. I have the graph up here more as a visual if you need it. But you don't have to use it. So here it goes. Write the equation of a hyperbola with vertices 3, 5. So I'm going to plot the point 3, 5, and it says it's a vertex. And 3, negative 7. So that's all the way down here. The foci are at 3, 7. And 3, negative 9. Alright, just like an ellipse, there's really 4 things you need to know. Is it horizontal or vertical? What's the center? And then what's your a squared and your b squared. So those are the things that we need to identify. Well, the center is the midpoint of the vertices of the foci. So you can either count or you can look. Let's just do it with the foci. 7 and negative 9. If you add those two numbers up, you get negative 2. You take half of it, you get negative 1. So the midpoint will be 3 comma, negative 2 divided by 2 would be negative 1. So at 3, negative 1 is your center. So we know the center is at 3, negative 1. So that's one of the things that we found. We also know that this is vertical. Could have determined that first because all your main points are vertical. You know the distance from the center to the vertex, 1, 2, 3, 4, 5, 6. And it should be 1, 2, 3, 4, 5, 6 on both sides. So we actually know that the a value is equal to 6, so we know a squared is equal to 36. So now we have a squared. The distance from the center to the focus is 8 units, which means we know c is 8, and we know c squared is 64. Now we're not looking for c squared, but we can help identify b squared by knowing the other two squareds. Remember the relationship is a squared plus b squared is equal to c squared. So let's plug that information in. 36 plus b squared is equal to 64. And so now when you subtract the 36, you will get b squared is equal to 28. We don't need to know b, we just need to know b squared. So we have b squared, a squared, vertical, center. We have all the things that we need to be able to write the equation. Sorry. And so here we go. Now it is vertical, so which squared term goes first? If it's vertical, think y-axis. Sorry, vertical, think y-axis, and so your y is the positive one. So you're going to start off with y not x. Y minus negative 1, so that's plus 1, squared, minus x minus 3 squared is equal to 1. Now, where does the a squared go and where does the b squared go? Well, remember the a squared goes with the positive squared term, so that'll be 36 with the y squared, and then the b squared goes with the negative squared term, which would be 28. Okay, So there's your equation given that information. Alright, here's one more example if you want to give it a try, and then you can ask me in class if you got it correct or not. But let's go ahead and take a look at the homework. Make sure you skip 21 and 22. We didn't cover those types of problems. And so this is going to be dealing with hyperbolas. So I'll go over a couple more of examples and talk about some of the key things that maybe we didn't get to talk a lot about, but we can do that in class as well. Thanks.